Hello student. In this video I am going to continue from the last one. We are discussing about various forecasting methods. Here I am going to start with measuring forecast error. Forecasts are never perfect, they never will be, because it's just a prediction like thing, and we just try to be accurate, not exactly accurate. There will be always some error. Suppose we use linear regression also. Then also we try to fit the data with some trend line. So obviously some points will be not in the line, so never it will be going to be perfect. Though you are going, if suppose you want to involve some polynomial functions also, you want to fit the data with some polynomial function equation, then also it might not be easy, or it will never be the point that all the points will be in the line, on the line. So there will be always some error in this forecasting case. So forecasts are never perfect. Need to know how much we should rely on or our choosing forecasting method. Means whatever forecasting method we are choosing, we need to rely upon, and we need to know how much we can rely upon. Measuring forecast error, that is E equal to T equal to AT and FT. Here AT is the actual value, or FT is a finding value. So actual value minus finding value, that will be the difference between that is error. Note that over forecast equal to negative error, under forecast equal to positive error. If AT is greater than FT, then that is under forecast. If AT is less than FT, then that is over forecast, negative errors, or under forecast, that is positive error. There are other method also to find the accuracy. This is just error. We measure the forecasting error. There are other techniques to measure the error or accuracy. Those are like mean absolute deviation, or MAD, or cumulative forecast error, CFE, mean square error, MSE, or tracking signal. So here mean absolute deviation is measure the total error in a forecast without regard to sign. Means we are not showing the negative or positivity in this part. We are just try to find the measure total error in a forecast without thinking about the sign, whether it is positive or negative error. We are not thinking about that, or do not think about that. That MAD equal to summation of all the actual values minus forecast values divided by n. That is, and so this is mean. This is a mean value about the differences between the actual and the forecast, and that is the absolute value. So no positive or negative here. This is the simpler value, actual minus forecast divided by n, and the summation is there. That is why this is the mean of all the error. And second one is cumulative forecast error, that is measures any bias in the forecast. So using this technique we can measure any bias in the forecast. That is, so summation of actual minus forecast, whatever it is, actual minus forecast, the summation of the difference between actual minus forecast. So the value of actual minus forecast might be negative or positive, but as a whole we'll sum up everything, and whatever we'll find, that will be cumulative forecast error, or it can be said as a bias in the forecast. Third one is mean square error, or penalizes larger errors. So here actually MSE is actually magnified version of the mean absolute deviation, because here you can see actual minus forecast is squared. So the negative values of actual minus forecast will also become positive, and actual minus forecast positive value will be same positive because the square, and summing up everything divided by n. So it is mean square error. So we are squaring the values, then we are taking the summation, then we are taking the mean. So penalizes larger error. so it might create some larger value due to the squaring of the values of the error. Again, tracking signal measures if your model is working, so that can be a very good one to measure the thing, that is, which is can be TS or tracking signal equal to CFE divided by MAT. That is actual forecast, that is summation of this divided by actual forecast at the absolute value. Okay, this is my minus and plus. So ultimately, so we can find by using this equation whether your model is working or not, or in a fixed way. So here, using this table, we can, a company is comparing the accuracy of two forecasting methods. Forecast using both methods are shown below along with the calendar values of January through May. The company also uses tracking signal with ±4 limits to decide when a forecast should be reviewed. Which forecast method is best? So method A and method B, where actual sales is this and forecasted sales is this. Then you need to find out the errors. So simple error is the difference between these two. Okay, difference between these two. Cumulative error is this summation of that actual minus forecast till that time. So initially this is cumulative error is 2, but at 1 this is 3 because this is summation actual minus forecast. But at this point 0, so 3 plus 0 3, and 3 plus minus 1 is 2. That is because this is only the simple actual minus forecast summation. But in case of mean absolute deviation, it will be absolute value. So that is not calculated here. Here only cumulative error is calculating, and also tracking signal is calculating. So try to fill it up using this equation, this table. Okay, to find out which method is more good. Here the company also uses tracking signal with ±4 limits to decide when a forecast should be reviewed. Which forecasting method is best? So if the tracking signal goes beyond +4 or -4, then that method will be reviewed. So here you can see tracking signal can be what in that situation. Here tracking signal equals CFE divided by MAD. CFE is what? 10 divided by 2 or 4.4, because CFE divided by MAD. So you need to find out MAD is 2 and CFE is almost 10, so that will become 5. So you need to review that method. So selecting the right forecasting model. The amount and type of available data is the main point of forecasting. Selecting the forecasting model. Some methods require more data than others, and some might require less data than others, and degree of accuracy is required. So using the equation of the accuracy or errors, we can find out the degree of accuracy. So increasing accuracy means more data. So obviously when you give more data input, then obviously your error might be decreased in some time. So anyhow you need to find out the degree of accuracy and relevancy of that accuracy level, and also length of forecast horizon. Different models for 3 months versus 10 years. Obviously if you are going to forecast something for 3 months, then the equation or the model should be different, and if you are going to forecast something for 10 years, then your equation might be different. And also presence of data patterns. If there are some patterns available in the data, then also it is important to choose different models with respect to that information. Lagging will occur when a forecasting model meant for a level pattern is applied with a trend. So different type of scenario, different type of forecasting model might be required. So that is why try to understand these 4 points while applying some forecasting model. And also there are various forecasting software available like Microsoft Excel, Quadro Pro, Lotus, or limited statistical analysis for forecast data. Or there are some statistical packages like SPSS, SAS, and CSS, or Minitab, forecasting plus statistical and graphics. Especially lead forecasting packages like Forecast Master, Forecast Pro, Autobox, SCA, like that. So I have not also mentioned the full form of all these softwares. Please go through these things in internet. You might find some interesting points about these softwares. Again, guidelines for selecting software. Does the you need to find whether the package have the features you want or not, or what platform is the package available for. How easy is the package to learn and use? Is it possible to implement new methods? Do you require interactive or repetitive forecasting? Do you have any large data sets? All those things need to be understand first. Is there local support and training available? Does the package give the right answers? There are other forecasting methods also, like forecasting, like developed by Bernie Smith, replies on the use of simple rules, the test rules on the past data and evaluate how they perform. Also, combining forecast means you can apply 2 or more forecasting method on the same data to improve the accuracy. And also there are collaborative planning, forecasting and replacements. Establish collaborative relationship between buyers and sellers, create a joint business plan, create a sales forecast, identify exceptions for sales forecast, resolve collaborated on exception items, create order forecast, identify exceptions for order forecast, or resolve collaborate on exception items, generate order. So these are various things that we can carry out using the forecasting methods at various situations. So please try to go through these things, this context, through the book also, through the literature also, and try to gain more knowledge on this. If you find any difficulty, please let me know. And also if you want to add something, then also let me know. We'll try to resolve all those things over Google Meet. Thank you.